Okay, what is a rational function? A rational function is a function of the form m of x over n of x, where m is a polynomial and n is a polynomial. You guys know what polynomials are, right? We studied that. So when you have a polynomial divided by a polynomial, we call it a rational function. Okay, now what we have to do tonight is we got to learn how to graph. Now, the other class already confirmed they know how to graph. Okay, let's do an easy one. 2x minus 1 over x plus 1. Now, when you graph rational functions, go through the 4 things that your teacher taught you last year. Plot the x-intercepts, the y-intercept, then put in the vertical asymptotes, and then the horizontal asymptotes. Okay, let's do that quickly. Okay, how do you find x-intercept? You substitute 0 for y. And if a fraction is equal to 0, does that mean the top is 0, the bottom is 0, or both? The top is 0. So what makes the top 0? 1/2. So right there. Y-intercept. Substitute 0 for x. The other class said, why are you holding your hand there? Look, I'm plugging in 0 for x. There's no x term. Y-intercept is like the easiest one to find. -1. Vertical asymptote. Where do I look for the vertical asymptote? The denominator. What makes the denominator 0? Okay, so what is the vertical asymptote? X equals negative. If you just say -1, it doesn't make any sense. Okay, somebody tell me, how do you graph -1? Yeah, that's right, it doesn't make sense. X equals -1. It's a line. You gotta give the equation a line. Now, horizontal asymptote. Now, by the way, remember we talked about why there's a vertical asymptote there? Last chapter? Because when you plug in a number very close to -1, the denominator is very close to 0. When you divide by a number very close to 0, it becomes really large. That's why you have a vertical asymptote there. Horizontal asymptote. Well, if you look in your notes, it tells you if the degree of the top and the bottom are the same, which they are, then you just look at the leading coefficients. 2 over 1. So y equal 2 will be the horizontal asymptote. So if the degree of the top and the bottom are the same, just look at the leading coefficients. Okay, now how do you graph it? Now, when you have a vertical and a horizontal asymptote crossing like this, it's a 50-50 shot. Either the graph is up here or it's down there. Which one do you think it is?
Up there.
Why does it have to be up here? How come it can't be down here? Yeah, because otherwise it would cross the x-axis, but there's no x-intercept there. So it has to be up there. Period 3 said, well, can't you just go around the x-axis like this? No. Because the x-axis goes forever that way. And on top of that, this is not a function. It doesn't pass the vertical line test, although it doesn't stop you guys, right? Some of your graphs are not even functions. It's crazy. Okay, and then on this side, either the graph is up here or down there.
It's down there.
Yeah, it's got to be down there because it's got to pass through these 2 points that you plotted, right? So it's got to be down here. And not only that, what did we learn last year? The vertical asymptote comes from the denominator, right? If you have an odd power on it, then what happens at the vertical asymptote? It goes opposite ways, like this, right? If there was an even power there, then they both go the same. Does that sound familiar? Just like the numerator tells you the x-intercept. If you have an odd power on it, it goes through. But if you had an even power on it, the thing would bounce off. So the powers are very important to look at. Okay, let's do do an example with powers now. How about x minus 1 squared all over x plus 1 squared x minus 2? Let's make up something. Okay, now tonight's homework is easy. If you know what you're doing, you can finish in 5 minutes. Because when you graph, I don't want to see a masterpiece. I just want to see a quick sketch. Like last year, like I told you, the graph was the answer, right? But then when you go to calculus, the graph is just to help you solve the problem. So you have to be able to sketch it very quickly. Okay, let's go through the four things. X-intercept, quick. What? 1. Your eye should go to the numerator. What makes the top 0? 1. Okay, y, I'm scared to even ask this. Y-intercept. Plug in 0 for x.
Negative, no, positive half. No, wait, half. Negative half. Negative half.
Negative half. I'll tell you right now, you get the y-intercept wrong, your graph is just screwed up already. Vertical asymptote. Your eye should go to the denominator. What makes the denominator 0? X. Okay, so negative 1, 2, so label it. X equals negative 1, x equals 2. Horizontal asymptote. If the degree of the top and the bottom are the same, you look at the coefficients. But here, the degree of the bottom is bigger.
0.
So it's y equals 0. Do I have to label it?
No.
Look over here, I labeled it. Do I need to label it?
Yes.
No, I did already. X-axis. X-axis is y equals 0. I labeled it already. Oh, but some of you don't put the x and y on the axis. So then you didn't label it then. Now look, hey, Mr. Park, there's a point right on the horizontal asymptote. Is that bothering you?
No.
Doesn't bother you. Doesn't bother me.
Because it goes through because it's.
Because last year, okay, what do you know about asymptotes? The graph gets closer and closer without touching. That's what period 3 said.
Did you find verify?
Okay, I'll tell you what. Horizontal asymptotes, I don't have time to explain why today, but okay, tomorrow we'll have more time. Horizontal asymptotes only take effect out here as x goes to infinity and x goes to negative infinity. So out here, the graph gets closer and closer to the horizontal asymptote. Out here. So just remember the pterodactyl. Ah! Like that. Out here. So inside here, the graph can cross horizontal asymptotes. In fact, it can cross multiple times. In fact, one of the problems on the next test is going to be, where does the graph cross its horizontal asymptotes? So do not be surprised over there. Okay, now we are ready to draw the graph. Now, out here, it's a 50-50 shot. It's up here or down there, but there's really no clues. So I wouldn't even do that first. I would see, here are the clues. You got points here. Okay, so look, here's the y-intercept. Either the graph is going to go up or it's going to go down and get closer to the vertical asymptote. Which one is it?
Down.
Yeah, it's got to go down. Why?
Because it crosses.
Because if it went up, it would cross the x-axis and there's no x-intercept there. That's the only time it touches the x-axis. Okay, now, so it's going to go to the x-intercept. It's either going to go through and then go up, or it's going to bounce off and go down. Which one do you think it is? Yeah, because 1 came from this factor. It has an even power, which means it's going to bounce off. So it's going to bounce off this x-intercept and then go down. How come period 3 says, how come it can't bounce off and then go up?
There's no more other.
Yeah, because if you bounce off and then you go up, it's going to cross the x-axis over there. There's no x-intercept. Okay, now it's easy. Look, negative 1 came from this factor, has an even power, which means they both go the same direction. So if this one is exploding down, then it's got to explode down on this side, so then it's got to be there. 2 came from this factor, odd power. So if it's exploding down on this side, that means on the opposite side, it's going to be exploding up. And then what do? Ah! See how, as you go out here, it gets closer to the horizontal asymptote? Only out here for horizontal asymptote. Is it starting to make sense now? We got time for, oh, this class we're kind of faster than period 3, but that goes without saying. Okay, let's do this then. Y equal x squared minus x minus 6 all over x squared minus 4. Who knows, some of these problems might be the same as your homework.
Factor.
So the first thing you should do is factor it, right? Because you have it in factored form, it's easier to see things. So factor the top. Factor the bottom. And what do you notice? Hey, let's cancel out.
You get a
Oh, something's going to happen when they cancel out, yeah, from last
puka
year.
hall.
No, yes, yes, it works.
There's a hall. You get the puka.
I'm not going to even acknowledge whole. Okay, so what you do, okay, forget about that for now. Just graph this, what's left over. This is the graph right now. Okay, do we know how to graph that? Yes, that's easy. X-intercept. 3. Y-intercept. 3 halves. Vertical asymptote. Come on, look at the bottom. It's supposed to be good already. Horizontal asymptote,
One,
the
one.
degree of the top and the bottom are the same.
One.
Look at the leading coefficients, so y equal 1. Okay, so on this side, is the graph up here or is it down there? Duh, look at this point, it's gotta be up here. And then since it's exploding up on that side, since the
Floating down.
odd power, it's exploding down on this side, and then no, that's all you gotta think. Bob said that's the answer. No, why not? Because if you look at the original problem, which is this, what's the domain? X cannot equal -2 or 2. So x cannot equal 2 because you got a vertical asymptote, but x cannot equal -2 either. So when x is -2, you have to put, what is that called? No. It's called a removable discontinuity. That's what it's called. Not a hole, not an open circle, not a puka. It's called a removable discontinuity, and you should also label that point. So, we know the x coordinate is -2. How do you figure out the y coordinate? You plug it in. Plug it into where though? Because if you plug it into this, you can get 0 over 0, which is only 5. You plug it into that, because that's the graph that we just drew, right? So if I plug in -2 for x, what do you get? -5 over -4, so that's 5 fourths. So 5 fourths. And make sure it's kind of accurate, yeah, it's good. So when factors cancel out, that's how you get the removable discontinuity. Is it all coming back? You guys are good at it. Okay, let's do one more example then. In fact, let's keep the same thing, except let's add a factor on the top. What do you want to do? Let's put x then. How is that going to affect it? Okay, now this is what I want tonight. I want you to do it quickly. X-intercepts.
0, 1.
0 and a 1. Y-intercept. That's a duh. If the x-intercept is 0, the y-intercept is 0. Has to be, right? Because otherwise, if you put a point somewhere else, it's not a function anymore. But it doesn't bother you, right? Vertical asymptote. X equals -1. Raise this. X equals 2. Horizontal. If the degree of the top and the bottom are the same, which they are, you look at the leading coefficients.
1.
Y equal 1. Okay, we are ready. Okay, so over here. Okay, look, this is, what do we know? What do we know? Okay, well look, this one's obvious. Is the graph up here or is it down there? It's gotta be up here because if it were down here, it would cross the x-axis, but there's no x-intercept there. Okay, now, since we know the graph is exploding up on this side, look, -1, we look at this, even power. So that means, gotta explode up, gotta be the same way. Didn't your teacher call it volcano last year? Mr. Rubash, volcano, right? Okay, whatever. Okay, now look, I'm coming down, because I gotta hit this point. Hey, I'm crossing the horizontal asymptote, is that a problem?
No.
No, that's not a problem, because horizontal asymptotes only take effect out there. Okay, now, do I go through this x-intercept, or do I bounce off it? Well, this is 0, it came from here, odd power, you go through it. Oh, but then there's another x-intercept.
You bounce.
1 came from here, even power, so you bounce off it, and then since the thing is exploding down, 2 came from here, odd power, it's going to explode up on the other side, and then what do I do? See, it's easy. Rational functions are actually easier to graph than polynomial functions because you have more clues. Question?
I don't understand why you go down and then you step up there.
Well, I started over here.
Oh yeah, but like, I don't understand how you get from there to there.
From here to there.
Yeah,
Because over here it's exploding down, right?
yeah.
You can't, well, after it bounces off, you can't explode up because then it would cross the x-axis, so it gotta go down, right?
I know, but then,
Okay, 2 came from this factor, odd
Yeah.
power. So if there's an odd power in the denominator, that means at that vertical asymptote, they're gonna go opposite ways.
okay.
Even power means they go the same way. See, like, This one here, even power, see how they went the same way? But when you have an odd power, they go opposite way. So that's why it's exploding down on this side, then on the other side gonna explode up.
Oh, okay.
Yeah, so the powers tell you everything. Stafford.
But it wouldn't be able to cross anyway because there's no X like and such
Where?
down there on the
On the
far
other side.
right. So then wouldn't you, isn't that like another clue?
Oh yeah, that would be another clue. So it has to be up here, because if it were down here, it would cross the x-axis, but there's no x-intercept there either. Yeah, so this one got, yeah, this one get plenty clues. That's what, it cannot go wrong, right? Okay, the bell's gonna ring in a minute. Ricky has it. Oh, you took off your mask. Never mind, too late.